Starting. Ready?
Yep,
Good.
good.
Hello, good afternoon, everybody, on our weekly Viking Malt webinar. Today you can see there is Raimo once again with us because last week we met Arta Savonen, who was explaining us the world of extracts. And we are coming back right now to the malt subject. And today's topic, it's going to be a malt analysis, where Raimo will definitely tell you a lot of new things which you probably didn't know about that what you are doing in the background to deliver you the best products from our company. What I want to say at the beginning, that it's going to be our last webinar before the summer holiday break. We will have a 2 months break on which we will work on the next very nice subjects for you, and we will try to start another series of webinars in the autumn after the summer holiday. Some technical details about our webinars. The webinar will take around 45-50 minutes. The first part is going to be a presentation from Raimo's side. We have around 16 slides, so it will take around 20-25 minutes maximum. And after that, we will start our standard question and answer session. So during the presentation, you are free to ask us a question. On the lower right corner, you have a type message window where you can write all the questions, and we will try to answer all the questions at the end. So we will not delay the presentation, and I'm giving back everything to Raimo. Raimo, start your webinar about malt analysis.
Okay. Hello from my side also. It's a very hot summer day here in Finland, and let's talk anyway something about malt analysis. Well, quite obvious question is that why analyses are done. Firstly, we guarantee our raw material. I think this is something that all malt houses do and want to have a best possible raw material for use. Then we do some analysis to check how is our malting process actually going. Is it like expected? Can we find something that needs to be done differently? Then with the analysis, we can create a COA, certificate of analysis, and by that we can give a brewer a good estimation about the malt and what to expect. And then of course research and development and many kind of troubleshooting what might occur, we do analysis for. This is a quite typical way to control malt quality. All malt houses won't do it exactly like this, but I think the main things are always in it. Even in Viking Malt, we have slight variation, but this is kind of a general presentation. So first we got the pre-sample of a barley lot, which is going to be raw material, most likely like a 1 kilo sample or so, to make sure it is something that we want. What kind of estimation it gives to a ready product. So we want to check that. If it's found good, then the actual lot comes to a malt house. That may be a huge tonnage of a barley. And then again, we make an even sample from that, make some analysis. Typical analysis are protein level. We will do a screening to find out the kernel sizes. We will do the germination, that it will germinate okay, and that kind of analysis. It needs to be quite close to the pre-sample. Of course, we check the variety too, so it needs to be very close to the pre-sample. Then we take once more the sample that we will take the barley to the steeping. This is just to make sure that we really know what we are going to process. We can check that we have ourselves stored the barley right. So the moisture has stayed on the right level as it was when it came in. We don't have too much broken kernels. We don't have any machine on the way from silos to steeping that will break down the barley, etc., etc., etc. So we will check once more. We can check also the variety that we are really taking the material from right silo, right raw material. Then during, of course, the malting process, we will take some moisture samples, but the malt batch sample after kilning and after decalming, we will do a check and make the basic analysis what kind of malt we did, and then we know all the details that when it goes into the malt silo, what variety is there, what are the parameters, what we have analyzed from it. Then, because later we will do a malt blend, let's say that we deliver Pilsner malt, it is always a blend of 2, 3 varieties. So then we know that in this silo we will have a variety A, and then the next silo variety B. We know all the analysis, so we can do the calculation, and when we do the blend, how it looks like when it's calculated. And before it goes to a customer, before backing, before putting in a railway wagon or bulk delivery, we will take a delivery sample and to check it once more, and it should be quite close to the calculated malt blend. Of course, some fluctuation always is, we come that to later, but quite close. By that way, I think this is quite common way for all malt houses to check the quality issues from barley to malt. Typical analysis is based when we're doing this EBC, like we do this in Europe. It's the Congress word that it is a kind of standard word, and it is made by rules of EBC Analytica. And I have described here what kind of process is it. So we take a 50 gram of milled malt, 200 ml distilled water, and then we have a steering with certain type of system, and there is this mashing program, and we go through the program, and it ends in cooling session, and then we use distilled water to make the weight exactly 450 grams. It will be filtrated with certain type of filtration paper, and if in question it is a kind of special malt, inactive malt, that needs to be done then 50-50 basis with the known Pilsner malt. Here are some pictures about how everything is set up. So in the right upper picture, it is this mill, and it is always calibrated in a institute that it's typically also sealed, that we don't do the adjustment ourselves. We have a couple of mills, and the one can be in calibration, and then we can get the use the other one, etc. In the right lower corner, a picture of a mashing system, and then the two pictures about wort, and there is a filtration going on, and somebody is taking a sample. But very clear rules and instructions how you should do this wort. we end up typically to a quite weak wort, like a 8.9 Plato wort roughly it is. And also good to notice that all the filtration and everything is done with the cooled wort. We can do this malt analysis also some directly from malt kernel. Good example is, for example, friability measurements. We can do also some screening, the kernel sizes directly from malt, but mainly major part is based on this Congress mashing and wort from it. I have a lot of questions from our customers that can we have some special analysis from certain special malts, but not all analysis can be done from special malts. And I think quite good example is is this let's say friability. If we have a caramel malt, it's quite hard in structure, and if we put it in a friability meter, it may change all the settings of this machine because the kernel is much more hard than it was expected to be. And of course, like if we want to create a mashing and create a wort from mash, and if it doesn't have any analysis, it's not going to be very reliable result then. One thing I keep on saying to our customers that you need to understand the Congress mashing result like a measuring stick. It is kind of what we have a one process to create wort, and you need to be able to estimate with that process how it's going to be in your own process. So it is kind of an estimation tool into your own brewing process, and you need to learn to have quite clear vision. If something is changing in a Congress wort results, how or with what kind of response it will make into your own brewing process. There are differences. For example, good example is wort extract. We may give extract content of 81 for Pilsner malt. Some malt house, you never reach the 81. You go a little bit lower all the time. But there are some quite sophisticated brew houses which can get more extract out of what the Congress wort expects. So you just need to understand how these results estimate your process. Of course, a good sampling is a basic demand for any reliable analysis and the results. So the sampling needs to be done very, very carefully. This is also a question when in some cases we may end up that the customer is having some kind of a problem which was not expected at all, and then we need to get maybe a new sample from a customer that we can analyze that again. Then it's very important that if you send some malt back to us and we want to do some verification of analysis, you need to take a very, very good sample what you got. It's not just take a spoonful on from the top, but you need to really take a sample from many places, a lot of small samples. This may be small, but it's one example of analysis result made from Pilsner malt production batch. We do quite much batches per year, and all analysis are all batches are analyzed more or less something like this. So we know what was the moisture, extract fine, extract coarse. Extract coarse is not analyzed daily, but we do it after certain periods to check it out. And then we have the extract difference, which is the calculated value. We check the color all the time, beta glucan levels, protein is checked, soluble nitrogen checked, and then of course the colba, then you can calculate it, free amino nitrogen checked. Then we have the activities, so diastatic power and alpha amylase, they are typically checked. And then we have the friability meter results, like friability, partly PUG and classic horns to check out those, and quite typically DMSP, because we need to know the DMSP also when the Pilsner malts are in a silo, and before we do the blend, we need to be sure. Quite many analyses actually, what we need to play all the time. So here is one picture about the friability meter. A lot of questions. I think brewers are quite interested in friability meter results, and it looks like this. On the left upper picture, you can see a friability meter working. There is a weighted amount of kernels inside the friability meter. On the next picture, you can see the sieve that is rotating there, and in the picture you can also see the arm, which is pressing with certain strength, and there is a rubber roll in it, and actually the sieve is going around and around, and the kernels are moving, of course, inside, and then we have this rubber roll which is pressing them, and little by little it's grinding the material through the sieve, and then we can get the friability meter figure, how much go through, and then what was left on top, like we can see in the middle picture, there are some kernels on top of the screen, so then you can measure that, and you can get this PUG, partly unmodified grains, and then you can also calculate the whole kernels, then, which you can say classic kernels. Of course, the more it goes through this sieve, the more modified the malt is. But now you can understand, for example, here, if you put caramel malts, which may be quite hard, a good example is a caramelized wheat malt, and that it's very hard, and maybe almost nothing comes out from that. So you can't just do all the special malt analysis. If you do special malts analysis with 50-50 basis, the wort, you can calculate easily back moisture. That's easy. You can calculate back the extract content also. That's easy. And then you can calculate back the color. The rest analyses are not very simple to tell exact result. Color measurements, which is very important to brew houses. They are also standardized methods. We have certain cuvettes, and you can see in the middle picture, in the lower row, there is the rolls of the where are different colors, and you use this with comparator, and you put the wort in a cuvette, and then you find out with these rolls at what is the match, and then maybe if it's directly the color range, or if you have some dark wort, you may have some dilution factors, and then you can multiply the right color, what you find from these rolls. Of course, the other possibility is to use the spectrophotometer, and then you get the color result. Quite typically, it is so that, for example, if we have a Pilsner malt result let's say the color is 3.0 with the comparator, then you measure it with the spectrophotometer, it's most likely it is something like 3.2 or close of that. So typically you get a little higher values from spectrophotometer. Then how we make sure that our results are reliable. Uh, we use the standardized methods. Calibration of the equipments are more or less done daily, and or at least according some quality instructions what are available, but more like very often. Malt laboratories take part into the ring tests, so we have certain malt which comes to us. We do the analysis, and malt from exactly similar type of malt are sent all over the world to different malt laboratories, and we should get similar results. And we also evaluate the results, and we can have a table that we know what is our malt laboratory's number, and we know what we got, and then we can check what have the other malt laboratories got, and we try to cooperate with that. That all malt houses would give very reliable results. We use also reference malts. There are so-called standard malts, and we analyze them together with our customer samples or batch analysis, and we have the reference malts going on. And this is to notice that if it starts to give different results that we are used to it, we would understand that something is wrong now, something is not going as expected. So this is quite important way of control our own analysis. We also keep statistics over all our results, and all results and even middle results. They're stored for later checkup. So there is a very nice transparency going on with the analysis. Well, so we can go back to this analysis and check out that what was the middle result, how was the calculation done, and if we have some suspect that the result is not correct. Anyway, we try to do very sharp and according all the rules, but there is quite tolerances. With some analysis there is more than the other. For example, beta glucan results, it may vary almost 15%. That's actually quite big variation, and by that way you can thinking if there's some kind of a limit value and you get 200 milligrams per liter, and you variate it with 15%, you can say that in another day you might have got 170, and it's as right as the next day somebody would analyze with beta glucan this 230, and it's also right. So no mistake is made, but anyway, there are some tolerance with this analysis. Also, quite big tolerances with soluble nitrogen, and it may easily in a level of 700 to 750 or 650 to 750, it can easily move and vary plus minus 40 units. And this may get also an effect to a Kolbach index if you calculate it, and someday you get it in a low and someday to the upper limit. Color, there is roughly 4.3, quite close, for example, to each other. Can say that both could be correct analysis. Accuracy, anyway, this is a table. I checked out some numbers from EBC Analytica, and you can here see that the beta glucan, for example, the second row where we have it's done from wort. There is put an average range up to 289, and if we do the small r 95, so we would do the same sample and it will be analyzed again. Here it says that between the same sample analysis from the same word, you can have a range of 11. But if we take a totally new sample and do all the word and everything again, then we end up of this 41 difference from the word. And so what is said here in a dark box, that many malt laboratories operate with more narrow R95 and big R95 range than what this EBC Analytica actually expects from the rules. So we really try to do the best what we can. But it's not super exact science anyway. So here you can see also the other numbers. What is color measurement is actually quite sharp. The difference sometimes if the laborant somebody checks some color hue a little bit more dark than the other, those may be the variation. Spectrophotometer checks all the time the same, but still you typically have a little bit higher color from spectrophotometer than with the comparator. Okay, then if we go to this how to read the malt analysis, I showed you earlier the long list of batch analysis, so you can have in your certificate of analysis from 2 to even 15, even more different analysis done. This is relating what we have agreed. Typically, customers that buy millions of kilos, they have a quite lot of demands, different demands, and we may do some special analysis what the others don't actually need. But the important thing is that the certificate of analysis, COA, you should always read it as a whole. So do not concentrate on one single parameter. Like in previous page, I showed you, or actually a couple of previous pages, that there is some analysis can variate and give a little bit false signal, but most likely they are not all variating in the same direction. So read it always as a whole. There are many different analyses that give parameters and measure the features of the malt from different angles. So you can have a quite wide view from a Pilsner malt, COA, for example. So keep in mind there is these tolerances in the accuracy, and sometimes there is some variation with one results, but it's not an error in a laboratory, or on the next day the malt would give maybe lower or higher value for certain analysis. This is just an example. I just took this table from my head. This is not any real analysis result, but you can see that, for example, beta glucan, then we have the friability figures, friability, PUG, partly unmodified grain, whole grain or classic grains. They tell about the and also homogeneity. They tell all of those tell us about how well and how far the malting has been going. Also, protein, soluble nitrogen, and kolba, they are strongly related to each other, and they are also strongly related to all other analyses what are mentioned here. So what I mean, if we check out the malt number 1, we can see the beta glucan level 150. It's good. Homogeneity very quite high, 90%. Friability, uh, well malted product, and the homogeneity tell that almost all kernels are on the same level. Then we have the PUG, which is 1. It's quite low. We don't expect to get any kind of problem. Whole kernels, so there is no very hard kernels that are not malted almost at all. It supports all the other analyses here. Protein 10.5 and 700 milligrams per 100 grams soluble nitrogen looks like a malt that has been malted quite strongly, and also this figure uh, supports the findings of beta 150, the friability 90, etc., etc. And then the Kolbe index, which can be calculated from soluble nitrogen and the protein. Then I have a malt number 2. All other analyses are exactly the same as malt number 1, but the beta glucan is very high, 295. I have a lot of questions from customers that if the beta glucan level even a little bit raises, they're huge worried about that now everything is ruined. We will get a problem with the word separation, etc., etc. But now again, if we see the big picture, most likely the beta glucan level and the analysis is not correct. Something most likely have gone a little bit wrong, because homogeneity, friability, PUG, whole kernels, protein, and related to soluble nitrogen and Kolbe index, they all tell that the malt is good and very well modified. So I wouldn't be very worried about this 295. Of course, that could be this high, but I would contact your maltster and ask them, and we could check out if there is maybe something wrong. Of course, we have a lot of checkups, but it's not super rare that you might have some kind of typo there. So it could be 195, and then if we figure out that there was almost this plus minus 40 difference between the days, how the beta glucan value might be, so that could be quite clear explanation of that. Malt number 3, then we can see that there is now the 295 is the beta glucan, quite on a high side. We can check out the homogeneity, 65. It's not very homogenic material. Friability is low, on the low side, 6.8. PUG high, very high, 8. And we have whole kernels, 3. And protein, 10.5, but still only 520 of the soluble nitrogen. And of course, by calculation, the Kolbe index is very low. Clearly not very far malted, I would say unmodified malt, and depending of the usage, but if it would be a base malt and used in a high dosages, most likely you end up having some kind of process problems. So this number 3 is typical at all, and all the analysis support that this is unmodified malt. Then number 4 is again quite similar than the number 1, which should be very well modified malt. And then we have a soluble nitrogen 520 and calculated with the soluble nitrogen protein level, the Kolbach index number is very low. So I would expect in here that, again, looking up about the whole picture, that the soluble nitrogen number is not good. It's not correct. So again, I wouldn't expect any kind of problem with this malt, but of course, just call your maltster and we could check out how are the soluble nitrogen in the middle results and if there is any kind of calculation error. You can end up having this at just one number mistake if you do it. We should have a quality that controls it, but things just happened when we send a lot of this analysis on the road all the time. We don't like to do that, but it just happens. Main thing here is look at your COA as a whole. Don't concentrate too much on one figure. It needs to fit with the others. Then we also do high gravity mashings, and this is already much more close to a real process. We adjust the pH a little bit, where we're going much higher in plateau, so roughly 16 plateau, and the filtration is done with hot wort, so more close to a real process. We can calculate wort filtration speed with that, so we take the first 15 minutes and 30 minutes, and so we can calculate also the filtration area, and we use this method widely in different kind of studies, a lot of when we change the crop, and of course on our ongoing R&D projects. This is a quite good estimation tool what really is happening. Okay, thanks. That was a half an hour punch almost from the Maltex analysis.
Thank you very much, Raimo. It was really interesting presentation, even for me, because I'm still learning something new each week about our molds and especially about those technical stuff. We have also some questions from our attendees, which I will start to read you right now. The first question: how is mill calibration done? Do you do it in your lab, or is it done by independent company?
Yes, it's a disc mill, so they will check out that all the mill discs are conditioned and they are sharp and they are renewed, and then they check up the distance that it actually is in a right distance between those two discs. And we don't do this ourselves. It's sent to an independent company, and they will do it, and they also will, how you say, make the adjustment. We can't do it. It's kind of sealed system, and as I mentioned, we have a couple of machines that the one is working, so then we can send the one to a calibration, because what I've learned, it doesn't happen in a day or two, so it typically takes time to send it and to get it back, and of course the work in between.
Good, thank you very much. The next question: how is percentage nitrogen of the Congress wort transformed into soluble protein percentage of the malt?
I'm not sure if I understand this now totally, but we could answer this later.
Okay.
Yes.
We will send Sherwin Canadian Malting Barley Technical Center. We will send you the answer later on. We will consult it also with our research and development department, I think. And if we wouldn't understand it well, so we will be in touch with you directly. Okay, let's go to the next one. So the next one I think is going to be a little bit easier. Why coarse grind is not reported in all COA? Is it important for new Viking malt users and good sales tool? It is needed to calculate the brewhouse efficiency.
Uh, Good question, actually, and this is also asked quite often. But the one and the main reason why we don't do it all the time from all batches, that it it takes the whole mashing process. So we need to do an extra analysis. It takes one place all the time from the uh, mashing bath that where we'll do it. So we do it in a weekly basis from our batches or so, but not all. Reason is that it takes our laboratory capacity too much.
Okay, thank you very much. Great. The next one. Is it possible to use this material when discussing with customers for X?
Yeah, sure. I think might be sometimes a helping tool and yeah.
And especially if you are familiar with those technical stuff, what you are describing us today during the presentation.
Hmm.
So it's hard to believe that Maltster is not double checking the analysis in case of extreme results out of specs.
We check them a lot, and of course we have uh, our laboratory personnel are very experienced, and they notice a lot of things, but sometimes just things happen, and there can be a kind of a typo or that kind of a mistake. We try to do our best all the time, and most what I would say reason for some is that there is some kind of a horrid situation or something. Not our target to make mistakes.
Okay. The next question is even the question which I wanted to ask you because you are a very experienced brewmaster. So, what parameter would you say is most important to you?
Well, I could loan one of my old colleague, one older brewmaster here in Finland. He used to always say that if he knows where the malt is coming from, all what he needs to know is the color. Then by heart he knows all the others. He's used to a certain malt house's quality.
Tricky answer.
Mm.
Okay, and I think it's the last question because I don't see that somebody's typing anything else. Okay, there is one more. Is blending of different malt batches allowed and normal routine in order to achieve specifications?
Good question. Also, this um, a bigger uh, brewing companies, the big ones, they have actually in their specifications when we need to, that they say that there needs to be minimum two different varieties or maybe three, and you need to do the malt batch, the mix that fits the uh, specification. And it's sometimes it's actually very good because in some year you may have an issue with one variety, and I have already during this lecture series explained how well we do the screening of the new varieties. But in some year it may give, for example, a slightly opal wort, which is not good. But if you mix just a few percent of another variety in it, there's no problem. Why this thing happens, I'm not sure that I can explain that, but it's one reason that to avoid that one variety in certain year could give you some kind of a problem. Very normal routine is that we blend several varieties together. Quite typical is anyway that you don't blend outside the spec, so you would need to have a good blend of very well malted varieties to blend.
Okay, thank you. And I think that's going to be the last question. Do you think that Arabinoxylan should be tested? Sorry, but I don't know even what is that.
Yeah, it's. I think it's not an issue with the barley or wheat malts, but it could be if you're playing with a lot of rye malts. So I think there is more issues with that. But so far, I think we have survived with this beta glucans analysis. But something to think anyway.
Okay. Thank you very much, Raimo. I think we have answered all the questions for today for this webinar. I don't see even that somebody else is typing anything. So we will be finishing soon, finishing in a moment. As I said at the beginning, we will do a break for a summer holiday. I would like to say a big thank you for all your attendings and for all the attendees to our webinars. If you would like to come back to our material, you can find it on our webpage in a section of how we can help, or you can follow the link, which I'm pasting it right now in a chat window. And you can also find those webinars on our YouTube channel, which I'm also pasting in a chat window. So you can come back to our webinars later on. You can use all our experience, or if you have any other questions, just don't hesitate to write to Raimo with everything what you could imagine. Raimo, do you want to say something for the end?
Oh, I wish a very nice summer to all of you, and I think we continue after summer break, somewhere after summer.
Okay, so have a nice summer and see you later. Thank you very much. Bye-bye.
Bye.